Hey there, science fans, it's Bill Nye here, and I'm thrilled to take you on an exciting adventure into the world of physics. You might be thinking, physics? That sounds complicated, but trust me, it's not as scary as it sounds. Physics is simply the study of how the universe works, from the tiniest particles to the largest galaxies. It's about understanding the fundamental laws that govern everything around us. Physics helps us explain why things move the way they do, why objects fall to the ground, and how energy travels from one place to another. It's the science that underpins our understanding of the natural world, and it plays a vital role in shaping our daily lives. From the moment you wake up to the time you go to bed, you're surrounded by physics in action. Think about it. Your alarm clock uses electronics based on the laws of physics to tell time. The sun, a giant ball of hot gas held together by gravity, provides the light and warmth we need to survive. Your car engine converts fuel into motion, allowing you to travel from one place to another. Even something as simple as throwing a ball involves concepts like force, velocity, and gravity. Over the next few minutes, we'll embark on a journey to explore the fundamental principles of physics. We'll break down complex ideas into bite-sized pieces, using clear examples and relatable analogies. So, buckle up and get ready for a fun and fascinating ride through the amazing world of physics. Hold on to your hats, folks. We're diving into the exciting world of motion. Everything in the universe is in constant motion, from atoms vibrating to planets orbiting stars. To understand motion, we need to talk about speed, how fast something moves. Imagine two cars racing. The one that finishes first has the higher speed. Distance is the total length traveled, while displacement is the change from start to end point. From pendulums to rivers, motion is everywhere. When we talk about speed, we often use units like miles per hour or kilometers per hour. These units tell us how far an object travels in 1 hour. A car cruising at 60 miles per hour, for instance, will cover 60 miles in 1 hour, assuming it maintains a constant speed. But speed isn't always constant, right? Sometimes things speed up, slow down, or even change direction. That's where the concept of average speed comes in handy. Average speed is the total distance traveled divided by the total time taken. Let's say you take a road trip. You might encounter traffic jams, winding roads, and pit stops along the way, causing your speed to fluctuate. However, by calculating the average speed, you can get a general idea of how fast you traveled overall. Understanding speed is essential in everyday life. It helps us estimate travel times, determine safe driving speeds, and even appreciate the incredible velocities of objects in the universe, like the speed of light, which clocks in at a mind-boggling 299,792,458 meters per second. Speed is just one piece of the puzzle when describing motion. To get the full picture, we also need to consider direction. Velocity is a term that encompasses both speed and direction. Imagine two cars traveling at 50 miles per hour. One car is heading north, while the other is heading south. Although they have the same speed, their velocities are different because they're moving in opposite directions. We can represent velocity using arrows. The length of the arrow represents the speed, while the arrowhead indicates the direction of motion. A longer arrow means a higher speed, while a shorter arrow means a lower speed. Understanding velocity is crucial for navigating our world. Pilots use velocity to chart flight paths. Sailors rely on wind velocity for navigation, and meteorologists track storm velocities to predict their paths and intensity. So, we've covered speed and direction, but what happens when an object's motion changes? That's where acceleration comes into play. Acceleration is simply the rate at which an object's velocity changes over time. In simpler terms, acceleration tells us how quickly something speeds up, slows down, or changes direction. When you press down on the gas pedal in your car, you're causing the car to accelerate. When you hit the brakes, you're causing it to decelerate, which is just acceleration in the opposite direction of motion. Acceleration isn't limited to straight-line motion. An object moving in a circle at a constant speed is also accelerating because its direction is constantly changing. Think about a car going around a roundabout. Even if it maintains a steady speed, it's constantly accelerating towards the center of the circle. Understanding acceleration is crucial for designing safe and efficient vehicles, predicting the trajectory of projectiles, and even comprehending the movements of planets and stars. It's a fundamental concept that helps us make sense of the dynamic world around us. Hold on tight, science explorers, as we delve into the powerful world of forces. Forces are what make the universe tick. They are the invisible agents of change, responsible for setting objects in motion, stopping them in their tracks, and even changing their shape. Imagine trying to move a heavy box. You push and you shove, and finally, it budges. That's force in action. A force is simply a push or a pull. It's an interaction between two or more objects that can cause a change in motion. Forces are all around us, constantly shaping and influencing the world we live in. Forces come in many different flavors. We have the force of gravity, which keeps us grounded on Earth. There's the electromagnetic force, responsible for the magic of electricity and magnetism. And let's not forget about the strong and weak nuclear forces which hold the very atoms in our bodies together. Understanding forces is crucial for understanding how things work. It's how we build bridges that can withstand immense weight, design airplanes that soar through the sky, and even understand the intricate workings of our own bodies. Of all the forces in the universe, gravity is perhaps the most familiar, yet also the most mysterious. It's the force that draws objects towards each other like an invisible cosmic hug. It's what makes apples fall from trees, keeps the moon in orbit around Earth, and even holds entire galaxies together. The strength of gravity depends on two main factors, mass and distance. The more massive an object, the stronger its gravitational pull. That's why the Sun, with its massive size, exerts a much stronger gravitational force than Earth, keeping all the planets in our solar system in its orbit. Distance also plays a crucial role in gravity's influence. The farther apart two objects are, the weaker the gravitational force between them. That's why we feel Earth's gravity much more strongly than the Sun's, even though the Sun is far more massive. Gravity is a fundamental force that shapes the universe as we know it. It's responsible for the formation of stars and planets, the ebb and flow of tides, and even the very structure of our own bodies. Imagine sliding a book across a table. It eventually comes to a stop, doesn't it? That's because of friction, a force that opposes motion between two surfaces in contact. Friction is everywhere, and while it might seem like a nuisance at times, it's actually essential for our everyday lives. Friction arises from the microscopic irregularities on the surfaces of objects. Even seemingly smooth surfaces have tiny bumps and grooves that interlock when they rub against each other. This interlocking creates resistance, which we experience as friction. The amount of friction depends on several factors, including the types of surfaces in contact and the force pressing them together. Rough surfaces like sandpaper create more friction than smooth surfaces like ice. That's why it's easier to slip on ice than on concrete. Friction plays a vital role in our daily lives. It's what allows us to walk without slipping, cars to grip the road, and brakes to bring vehicles to a stop. Imagine a world without friction. It would be a chaotic and slippery place indeed. Sometimes forces acting on an object balance each other out, resulting in a state of equilibrium. In this state, the object's motion remains unchanged. It's like a tug of war where both teams are equally matched, and the rope doesn't move. Think of a book resting on a table. Gravity is pulling the book downwards, but the table exerts an equal and opposite force upwards, supporting the book's weight. These two forces are balanced, so the book remains at rest. Equilibrium doesn't always mean an object is stationary. A car traveling at a constant speed in a straight line is also in equilibrium. The force propelling the car forward is balanced by forces like friction and air resistance, resulting in a constant velocity. Understanding equilibrium is crucial in many fields. Engineers use it to design stable structures like bridges and buildings. Physicists use it to analyze the motion of objects in various systems, and even biologists use it to understand the balance of forces within living organisms. Fasten your seatbelts, science enthusiasts. We're about to explore energy, the lifeblood of the universe and the force behind every action and change. In simple terms, energy is the ability to do work, applying force to move something. Energy comes in many forms: kinetic, potential, thermal, and more, constantly transforming, powering our world. Understanding energy unlocks the secrets of everything from atoms to galaxies. Kinetic energy is the energy of motion. Anything that moves has it, from roller coasters to rushing trains. The heavier and faster something is, the more kinetic energy it has. A bowling ball rolling at the same speed as a tennis ball has more kinetic energy because it's heavier. Kinetic energy powers our cars, planes, and trains. It's all around us, driving the world forward. Let's explore potential energy, the energy of position or stored energy. Imagine a roller coaster perched at the top of a hill. It's not moving, but it has tremendous potential energy due to its height. Potential energy can also be stored in stretched or compressed objects like springs or rubber bands. Even when things seem still, there's often energy waiting to be unleashed. The universe is a symphony of energy transformations, a constant dance of energy shifting from one form to another. This fundamental principle, known as the law of conservation of energy, states that energy cannot be created or destroyed, only transformed from one form to another. Think about a simple act, like turning on a light bulb. When you flip the switch, electrical energy flows through the wires, transforming into light energy that illuminates the room, and thermal energy that heats the bulb. The total amount of energy remains constant, even though it has changed forms. Energy transformations are happening all around us, all the time. Plants capture light energy from the sun and convert it into chemical potential energy through photosynthesis. Our bodies convert the chemical energy stored in food into mechanical energy to power our muscles and thermal energy to maintain our body temperature. Understanding energy transformations is crucial for developing new technologies and solving global challenges. For instance, solar panels convert light energy into electrical energy, providing a clean and sustainable source of power. By harnessing the power of energy transformations, we can create a brighter and more sustainable future. Get ready to dive into the fascinating world of matter, the stuff that makes up everything around us. From the chair you're sitting on to the air you breathe, it's all matter. And what's even more amazing is that all matter is made up of tiny particles called atoms. Atoms are incredibly small. Imagine shrinking yourself down to the size of an ant, and then shrink yourself a million times smaller. That's about the size of an atom. Despite their minuscule size, atoms are incredibly important. They're the building blocks of everything we see, touch, taste, and smell. Now, atoms themselves are made up of even tinier particles called protons, neutrons, and electrons. Protons and neutrons hang out together in the nucleus, the atom's central core, while electrons zip around the nucleus like tiny planets orbiting a star. Understanding atoms is like discovering the secret code of the universe. It helps us understand why different materials have different properties, how chemical reactions occur, and even how stars generate energy. Just like a chef uses different ingredients to create delicious dishes, the universe uses elements to create all the matter we see around us. Elements are the fundamental building blocks of matter, each with its own unique atomic structure and properties. Imagine a giant periodic table like the one you might have seen in a science classroom. Each box on that table represents a different element, from the simplest hydrogen with just one proton in its nucleus, to heavier elements like gold, iron, and uranium, with many more protons and neutrons in their atomic cores. Each element has its own unique personality, so to speak. Some, like oxygen, are essential for life as we know it. Others, like gold, are prized for their beauty and rarity. And some, like uranium, possess radioactive properties that can be both beneficial and dangerous. The incredible diversity of the universe, from shimmering stars to lush forests to the human body itself, arises from the unique combinations and interactions of these fundamental elements. Atoms are social creatures. They like to bond with each other to form larger structures called molecules. A molecule is simply two or more atoms held together by chemical bonds, like tiny Lego blocks snapping together. Water, for example, is a molecule made up of two hydrogen atoms bonded to an oxygen atom, or H2O. The bonds between these atoms give water its unique properties, like its ability to dissolve many substances and its high boiling point. Molecules come in all shapes and sizes, from simple molecules like water and carbon dioxide to incredibly complex molecules like DNA, the blueprint of life. The arrangement of atoms within a molecule determines its properties and how it interacts with other molecules. Understanding molecules is like learning the language of chemistry. It allows us to create new materials with specific properties, develop life-saving medicines, and understand the complex processes that occur within living organisms. Matter exists in different states: solid, liquid, and gas. Water is a great example. It can be ice, liquid, or steam. The state depends on how atoms or molecules are arranged and move. But there's more, like plasma, found in stars and lightning. Matter is truly fascinating. Hold on to your lab coats, science sleuths, because we're about to uncover how physics is the ultimate problem solver. Throughout history, humans have faced countless challenges, from building towering structures to communicating across vast distances, to understanding the very nature of the universe. And time and again, physics has provided the tools and insights needed to overcome these obstacles. Think about ancient civilizations constructing massive pyramids and temples. They didn't have modern cranes or bulldozers, yet they managed to move and lift colossal stones with astonishing precision. How did they do it? By applying basic principles of physics like levers, ramps, and rollers, they were able to amplify their strength and ingenuity to achieve remarkable feats of engineering. Today, physicists continue to tackle some of the world's most pressing problems, from developing renewable energy sources to curing diseases, to exploring the vast unknowns of space. By unraveling the fundamental laws of nature, physicists are constantly pushing the boundaries of what's possible and shaping a brighter future for all. Look around you. The world is brimming with technological marvels that would have seemed like science fiction just a few decades ago. From smartphones that fit in our pockets to spacecraft that venture into the cosmos, these innovations are a testament to the power of physics in action. Consider the smartphone, a ubiquitous device that has revolutionized communication, information access, and entertainment. At its heart lies a microchip, a marvel of miniaturization made possible by our understanding of semiconductors and the behavior of electrons at the nanoscale. The internet, connecting billions of people worldwide, relies on fiber optics, which transmit data as pulses of light through thin glass fibers, exploiting the principles of wave optics. But the technological revolution powered by physics goes far beyond gadgets and gizmos. Medical imaging techniques like X-rays, MRI scans, and ultrasounds allow us to peer inside the human body without invasive surgery, leading to earlier diagnoses and more effective treatments. Renewable energy technologies like solar panels and wind turbines harness the power of nature to provide clean and sustainable alternatives to fossil fuels. As our planet faces unprecedented challenges from climate change and resource depletion, physics is playing a pivotal role in developing innovative solutions for a sustainable future. By understanding the fundamental principles governing energy, materials, and the environment, physicists are leading the charge in creating a world where human progress can coexist with a thriving planet. Renewable energy sources like solar, wind, hydro, and geothermal hold immense potential to meet our growing energy demands without relying on finite fossil fuels that contribute to greenhouse gas emissions. Physicists are at the forefront of developing more efficient solar panels, designing wind turbines that harness the power of the wind more effectively, and exploring innovative ways to store and distribute renewable energy. Beyond energy, physics is also contributing to advances in sustainable transportation, agriculture, and building design. From electric vehicles and high-speed rail to precision agriculture techniques that optimize crop yields and reduce waste to green building materials that enhance energy efficiency, physics is paving the way for a future where human ingenuity and environmental stewardship go hand in hand. Despite the remarkable progress made in understanding the universe and harnessing its power, physics is far from a finished book. In many ways, we are still at the dawn of scientific discovery, with countless mysteries yet to be unraveled and fundamental questions still unanswered. What is dark matter, the elusive substance that makes up the majority of mass in the universe, but remains invisible to our telescopes? What is dark energy, the mysterious force driving the accelerating expansion of the cosmos? How can we reconcile the seemingly incompatible theories of general relativity, which governs the behavior of massive objects like stars and galaxies, and quantum mechanics, which describes the bizarre world of atoms and subatomic particles? These are just a few of the profound questions that continue to captivate physicists and inspire them to explore the frontiers of knowledge. The quest to understand the universe is a never-ending journey, and with each new discovery, we gain a deeper appreciation for the elegance, complexity, and sheer wonder of the natural world. Well, science fans, we've reached the end of our whirlwind tour of physics. But our journey of discovery is just beginning. Physics is like exploring an endless universe of knowledge, with new wonders always waiting. From quantum mysteries to the secrets of the cosmos, there's always more to learn. Who knows, maybe one of you will unlock the next big discovery. Now I know what you might be thinking. Physics sounds cool and all, Bill, but isn't it just for super geniuses with crazy hair and lab coats? Not a chance. Physics is for everyone, regardless of your background, interests, or hairstyle. Whether you're a student, a teacher, a musician, an athlete, or just someone with a curious mind, there's a place for you in the world of physics. You don't need a fancy lab or a PhD to appreciate the beauty and power of physics. It's all around you, just waiting to be discovered. Next time you see a rainbow, think about the physics of light and how different wavelengths of light are refracted and reflected to create those stunning colors. When you listen to music, consider the physics of sound waves and how they vibrate our eardrums to create different pitches and tones. Even something as simple as baking a cake involves physics, from the heat transfer that causes the batter to rise to the chemical reactions that create its delicious flavor. The most important thing is to cultivate a sense of curiosity and wonder about the world around you. Don't be afraid to ask questions, even if they seem silly or obvious. Some of the greatest scientific discoveries have come from people who dared to question the status quo and explore the unknown. Remember, science is not about memorizing facts or formulas. It's a way of thinking, a process of observation, experimentation, and discovery. It's about asking questions, challenging assumptions, and searching for evidence to support our ideas. And it's a journey that never gets old. So embrace your inner scientist, folks. Ask questions, explore your surroundings, and never stop learning. The world is your laboratory, and the possibilities for discovery are endless. As you continue your exploration of physics, remember that the most important question to ask is why? Why do objects fall to the ground? Why is the sky blue? Why do magnets attract certain metals but not others? Why does time seem to flow in only one direction? These are the kinds of questions that have driven scientific inquiry for centuries, and they continue to inspire us to delve deeper into the mysteries of the universe. Don't be afraid to challenge conventional wisdom, or to come up with your own theories and hypotheses. Some of the most groundbreaking scientific discoveries have come from people who dared to think differently and to question long-held assumptions. Remember, science is not about being right or wrong, it's about seeking truth through observation, experimentation, and open-mindedness. It's a process of continuous learning and refinement, and even the most brilliant scientists are constantly revising their understanding of the world based on new evidence and insights. As we conclude our journey into the fascinating world of physics, I hope you've gained a newfound appreciation for the beauty, power, and sheer wonder of the natural world. From the tiniest subatomic particles to the largest galaxies, the universe is a symphony of interconnected phenomena, all governed by the same fundamental laws of physics. Remember that the pursuit of knowledge is a lifelong adventure. There's always something new to learn, another mystery to unravel, another puzzle to solve. So keep exploring, keep questioning, and keep your sense of wonder alive. Our universe awaits.